Hello everyone, I'm Kimhongil. From now on, I am going to present the topological insulator for about 5 to 10 minutes. The table of contents is as follows. Let's look at the definition of the topological insulator, the advantage of the topological insulator, and the application of topological insulators. First, what is the topological insulator? We have to know topological and insulator separately. At first, what is topology in a topological insulator? Topology means like space. It means location and state. For example, can we make this chocolate without attaching or cutting or drilling this clay? The answer is yes. In terms of topology, these two objects are considered the same topology. Then, can you make a donut shape by using clay? That's impossible. In terms of topology, these two objects are considered the different topology. In short, you can think of it as topologically different depending on the number of holes. It is very important. Then, what is the insulator? The definition of insulator we commonly know is non-electric materials. Yes, it is correct. However, from a quantum mechanical point of view, it refers to an object that is full of electrons and cannot move. Since electrons cannot move, of course, we can see that current does not flow. In this figure, let's think of the person is an electron. There is a pool of persons in subway, and they cannot move. Like this, if this is a material that is filled with persons, is called an insulator. To understand this topological insulator, we need to know the quantum Hall effect first. Then we have to know Hall effect. The Hall effect refers to a phenomenon in which electrons are subject to a force in a vertical direction when a magnet is positioned in a conducting wire through which current flows. If so, consider the quantum Hall effect as well. The condition is that of a very strong magnetic field and the temperature close to absolute zero in a two-dimensional plane region. If you look at the graph at this time, it looks like a staircase. This staircase shape means quantization, and as a result, a scientist, Saulet, tried to connect it based on the fact that the number of holes in topology is integral individual. And it was proved in 2016, and they got Nobel Prize. Now, because the magnetic field is very strong, electron spins. Of course, the current does not flow because they spin in the insulator. However, if you look closely at the movement of this electron, you can see that it is spinning in a semicircular orbit, not in a full orbit at the edge. So when I analyzed all of these corners, we can find that current flows through the corners as shown in the figure. When it comes to topological mathematics, it can be seen that electricity flows unconditionally in any phase if there is an edge. This is called a phase insulator, or in other words, topological insulator. Now, let's find out the advantage of a topological insulator. Unlike general conductor, there is no resistance in topological insulator because current flows quantum dynamically. In other words, there is no heat loss as the temperature rises due to electrical resistance. This can be a material for quantum computer or various future products. Let's find out how to use the topological insulator. First, this material called bismuth selenide has the properties of the aforementioned topological insulator. This means that current flows only on the surface and the inside is non-conductors or insulators. But when energy is applied, current can flow inside as well. Using these points, it is used as an optical switch using light. It is also used as a material through which light passes only at the edge by using the point where current flows only at the edge. In addition, studies on lossless lasers and superconductors using the fact that there is no heat loss are being actively conducted. It can be seen that the possibility of development is endless, as it is a substance that has just been discovered. Thank you for your attention.